So we will first see about little historical background of X-ray. Discovery of X-ray. X-ray was discovered by W.C. Röntgen, William Conrad Röntgen, that is the full name. So he is a German physicist. Discovered X-rays in 8th November 1895. So 8th November, now we celebrate 8th November as International Day of Radiology. Sir also obtained a Nobel Prize in Physics in 1901. So in honor of his accomplishment, International Union of Pure and Applied Chemistry, IUPAC, named the element Röntgenium, the 111th element of the periodic table as Röntgenium in honor of his accomplishment. So you are seeing this Röntgen's laboratory in the figure where he discovered his X-rays and where he conducted all his experiments. So how X-rays were produced? Röntgen was working on Crookes tube. Crookes tube is nothing but glass tube, similar to that of cathode ray tube. He was working on Crookes tube and he was conducting experiments on light phenomenon and other emissions generated by discharging electric current. So the Crookes tubes contain two electrodes, positive and negative electrodes. So this Crookes tube, glass tube is evacuated and it is also shielded with a heavy black cardboard. So he observed that when a display of a fluorescent glow when high voltage is passing through this tube. The green fluorescent light caused a platinum-barium screen, which is 9 feet away from this apparatus glow. This glow was observed too far away for reacting to the cathode rays. So further, he conducted experiments and revealed that this new type of X-ray was capable. This new type of ray was capable of passing through most substances, including soft tissues of the body, and also let bonds and metal visible. So Röntgen named this unknown rays as X-rays, and he first experiment was conducted on his wife's hand by placing his wife's hand into the beam of X-ray, and first radiograph was taken. When he developed the plate, outline of her bonds and hand could be seen. And in the figure, you can see that radiograph of Röntgen's wife, and the dark spot is the ring that she was wearing at the time of exposure. So now we will see little bit properties of X-rays. X-rays are electromagnetic radiations of shorter wavelength, that is of few millimeters, is few nanometers. They travel in a straight line with a velocity equal to that of light. X-rays are not influenced by electric or magnetic field. That is, it cannot be deflected by either electric or magnetic field. X-rays penetrate through substances that are opaque to visible light. X-rays produce fluorescence in materials like calcium, tungsten, zinc, cinnamide, sulfide, etc. These are due to chemical changes in that elements. So X-ray produces chemical changes in the metals through which it passes. So X-rays affect photographic film and form latent image. X-rays produce ionization and excitation in the substances through which they passes. This also that is X-ray produces biological effects in the living organism mechanisms. It can either damage the cells or about produced. So, X-rays are produced when a fast-moving electrons are stopped by the means of target materials. Uh, when a fast-moving electron is suddenly stopped by any target material, X-rays are produced. That is how when the moving electron, that is the moving electron possesses some kinetic energy. Any moving object is having kinetic energy. Let we say half mv square. So when electron is suddenly stopped, the kinetic energy is converted into another form of energy. Here it is heat and X-ray photons. This conversion takes place in metal targets. So here out of total energy is converted into heat and X-rays. 1% of X-rays and 99% target. Therefore, the interaction of electrons with the target is the basis of X-ray production. Efficiency of the X-ray production. So, in order to prevent this, mainly glass tube is maintained in vacuum condition. Inside glass tube is maintained in vacuum condition. And also, the vacuum is maintained to prevent the oxidation and the burnout of the filaments. Now, the next is cathode assembly. Cathode assembly consists of a focusing cup. Now, focusing cup is made of molybdenum. Molybdenum is using because molybdenum is having high melting point, and also molybdenum is a poor thermionic emitter. So electrons aren't released to interfere with the electron beam from the filament. As I have told, filament is producing electrons. From filament, electrons are emitted. Suppose if electrons are emitted from the focusing cup also, it will affect the efficiency of the X-ray production. So focusing cup should be a poor thermionic emitter, so that electrons does not emit from the focusing cup. And molybdenum is used as it is negatively charged. And is used as cathode and filament are exchangeable terms only for this X-ray tube, not for any other diode tubes and all. Also has a connecting wires which supply both voltage, average about 10 voltage, and ampere average about 3 to 5 ampere, that heats the filament. Thorium is having atomic number 90. Both efficiency of the thermionic emission and long life of the filament are improved. In certain cases, thorium is also used along with the tungsten to increase the efficiency of the thermionic emission and long life of filament. As the thermionic emission occurs at 2000 to 2400 degrees Celsius. So filament has to be heated to 2000 degrees Celsius in order to happen the phenomenon called thermionic emission, so that electrons are emitted. A current is applied through the cathode filament, which heats up and releases electrons by thermionic emissions. The electrons are accelerated towards the positive anode of the tube voltage applied across the tube. At the anode, 99% of the energy from the electron is converted into heat and only 1% is converted into useful X-ray photons. Now we are moving to anode assembly. Anode assembly consists of a tungsten target, anode hood, and the positive potential. Anode in X-ray tube is a metal target electrode of high Z material, where electrons strike for X-ray production. The anode consists of focal spot that gets bombarded by electron stream, liberated and accelerated from the cathode. Anode is nothing but a small plate of target metal plate of placed in the anode. So the anode, that metal plate is made of tungsten. Tungsten is used because tungsten is having high atomic number, and it is also having high melting point and high thermal conductivity. Tungsten, being a high Z material, is preferred as target material for its good efficiency of X-ray production. And also tungsten has high thermal conductivity. As I told, electrons from the cathode is falling on the tungsten target. And we know that out of total energy, 99% of the total energy is converted as heat. So the all heat is produced here in the tungsten target. So the target should be able to sustain a high temperature. So a metal should be having high thermal conductivity, and also it should have high melting point so that it does not affect or melt the target. This helps to prevent the cracking or pitting of the anode surface by withstanding the excess amount of heat produced during the X-ray production. There are two types of anode mainly. One is stationary anode and other one is the rotating anode. First we will see stationary anode. Stationary anode is a small plate of tungsten. Small plate of tungsten which is having a dimension of 2 to 3 millimeter thick, which is embedded in the large mass of copper. In figure you can see this is the tungsten target and it is placed in the copper anode. The main function of copper is to support the tungsten target, and it removes heat efficiently from the tungsten target. As you know, copper is a good conductor, so that the whole heat produced in this tungsten target can be conducted efficiently removed through this copper anode. Plate. The anode is plate square or rectangular in shape, which is having a dimension of greater than 1 centimeter, and anode is tilted about an angle of 15 to 20 degree. This is to achieve line focus principle. And second type of anode is rotating anode. Here the anode is rotating continuously, and In stationary anode is not rotating. So X-ray tube capable of withstanding the heat generated by large exposure. Here, as the anode is rotating continuously, it is able to withstand large exposure of heat, as it is not as the electrons from the filament is not hitting the same place continuously, because this anode is rotating. This is one way to achieve cooling effect. Spread the heat produced during an exposure over a large area of the anode. As the anode is rotating, the heat is spread throughout this area of the anode. The main parts of rotating anode are anode disc, stem, rotor, and bearings and stators. Anode disc is made of tungsten, as we know why tungsten is chosen. And the anode disc is made to rotate about 3,600 rotations per minute. This facilitates the electrons to bombard a constantly changing area of the target. Anode also is beveled. Anode is having a beveled edge. You can see in the second figure. The angle of bevel is 6 to 20 degree. This is to achieve line focus principle. In stationary anode, line focus principle is achieved by tilting the end. target material for its good efficiency of X-ray production. And also tungsten has high thermal conductivity. As I told, electrons from the cathode is falling on the tungsten target. So and we know that out of total energy, 99% of the total energy is converted as heat. So the all heat is produced here in the tungsten target. So the target should be able to sustain a high temperature. So a metal should be having high thermal conductivity, and also it should have high melting point so that it does not affect or melt the target. This helps to prevent the cracking or pitting of the anode surface by withstanding the excess amount of heat produced during the X-ray production. There are two types of anode mainly. One is stationary anode and other one is the rotating anode. First we will see stationary anode. Stationary anode is a small plate of tungsten. The small plate of tungsten which is having a dimension of 2 to 3 millimeter thick, which is embedded in the large mass of copper. In figure you can see this is the tungsten target and it is placed in the copper anode. The main function of copper is to support the tungsten target and it removes heat efficiently from the tungsten target. As you know, copper is a good conductor so that the whole heat produced in this tungsten target can be conducted efficiently removed through this copper anode. Plate. The anode is plate square or rectangular in shape, which is having a dimension of greater than 1 centimeter, and anode is tilted about an angle of 15 to 20 degree. This is to achieve line focus principle. And second type of anode is rotating anode. Here the anode is rotating continuously, and in stationary anode is not rotating. So X-ray tube capable of withstanding the heat generated by large exposure. Here as the anode is rotating continuously, it is able to withstand large exposure of heat, as it is not as the electrons from the filament is not hitting the same place continuously, because this anode is rotating. This is one way to achieve cooling effect. Spread the heat produced during an exposure over a large area of the anode. As the anode is rotating, the heat is spreaded throughout this area of the anode. The main parts of rotating anode are anode disc, stem, rotor, and bearings and stators. Anode disc is made of tungsten, as we know why tungsten is chosen, and the anode disc is made to rotate about 3600 rotations per minute. This facilitates the electrons to bombard a constantly changing area of the target. Anode also is beveled. Anode is having a beveled edge. You can see in the second figure. The angle of bevel is 6 to 20 degree. This is to achieve line focus principle. In stationary anode, line focus principle is achieved by tilting the entire anode target to 15 to 20 degrees Celsius. Here you can see. In rotating anode, beveled edge are used. The angle of bevel is 6 to 20 degrees. Here the target area is increased but effective focal size remains same. Stem is the anode stem. Anode stem is made up of molybdenum and 90% of tungsten and 10% of tritium. Molybdenum is used because it is having high melting point and poor heat conduction. And this increases resistance to surface roughening and increases thermal capacity. The anode stem is usually of molybdenum because the heat produced in the tungsten anode should not be conducted to the other parts of the anode. See, the purpose of the anode stem is to prevent the flow of heat from tungsten to bearing of the anode assembly. The anode assembly contains starter, which is having starter and bearings, which is made of copper and some other metals. If heat is transferred to this part, the binding and all will be binding and all will melt, which will affect the working of the X-ray tube. So anode molybdenum stem is used. The other parts are router, which is made of copper and cylinder, which is a copper cylinder as you see in the figure, and bearing, which is contains metallic lubricants, silver and all, and starter. Focal spot. Focal spot is the volume of target material that gets bombarded that gets bombarded by the electron stream, liberated and accelerated from the cathode. Focal spot size should be as small as possible in order to attain sharp and higher quality images. Smaller the size of the focal spot, more heat per unit area will be produced, and this limits the current and exposure of the tube. If the focal spot size is too line focus principle, providing angle to the anode, that is 6 to 20 degree and 12 to 15 degree most common. So electrons are hitting this anode, and from this X-rays are produced and falls. So the anode is tilted to attain line focus principle. The anode angle is about 6 to 20 degree for uh, and most commonly found 6 to 20 degree. Most commonly used X-ray tube contains anode angle as of 12 to 15 degree. Anode angle reduces the length of actual focal spot but does not changes the width. This anode angle causes the effective focal spot length to be smaller than actual focal spot length. This could produce target size of 0.1 millimeter square to 2 millimeter square in X-ray tube. Line focus principle. The mechanism of foreshortening the focal spot length and so as the size as viewed down the central ray by angling the anode surface is called the line focus principle. The reduced size focal spot is called as apparent or projected focal spot. With this geometry, the X-ray appears to originate from a smaller volume than actual volume that absorbs electrons. So electrons falls in this area, and as the anode is tilted, it apparently reflect in a small area. Suppose as shown in the second diagram, let this area, you can see A, this as per the diagram, A is the dimension of the focal spot. Then the apparent focal spot is this small letter A can be this can be determined by sine of theta, that theta is the angle between theta is the this angle, and by taking sine of angle theta, that is opposite side by hypotenuse, that is alpha by A gives sine theta, that is alpha is equal to A sine theta. Space charge effect. It is the inability to obtain it is the inability to operate the current and voltage of the X-ray tube independently. When filament is heated, emissions of electrons take place. In the absence of high voltage, these electrons remains around the filament, and this cloud repels new electrons from the filament, and this tendency is known as phase charge effect. When filament is heated, electrons are emitted. due to the principle of thermionic emission. These electrons, if there is no potential given across the electrodes, the electrons will be just standing outside this filament. It won't be accelerating towards the anode. So that will create a cloud of electrons around the filament. This cloud of electron is having a negative charge, and that will repel the electron produced from the further electrons produced. So this will this effect is called as space charge effect. Since space charge is negatively charged, so its presence around the filament prevents further emission of electrons. When high voltage is applied, electrons move towards anodes. Therefore, space charge effect is diminished. As soon as we increases the potential across this electrode, the electrons from the filament side will be accelerated towards the anode side, and that will reduce the space charge effect. Tube current. Filament current is not tube current. It is the rate of electrons from the filament to target, or electrons per second is the tube current. As the electrons flowing from filament to an anode, current will flow from cathode side to anode side to cathode side. Tube current is measured in milliamperes, and it is limited by filament emission and space charge. Kilovoltage and space charge. Well, from this graph, while raising this graph, you can see it is plotted against tube current and tube voltage. While rising the kVp, gradually overcomes the space charge effect. So as tube current. So filament current is not tube current. Actually, we may confuse with filament current and tube current. It is the rate of electrons from the filament to the target. That is the tube current. That is electrons per second, and it is measured in milliamperes and limited by filament emission and space charge. So kilovoltage and space charge. Rising kVp gradually overcomes the space charges. As you can see in this figure, plot, which is plotted against tube current and tube voltage. As tube voltage increases, tube current also increases to 40 k up to 40 kVp. So higher fraction of electrons cannot may make it to anode as kVp increases. Below 40 kVp, current flow is limited by space charge effect only. As you increase the voltage, current flow also increases. That is, you can see a straight line here. Above 40 kVp, space charge has no influence on current flowing through the X-ray tube. As increases. Below 40 kVp, current flow is limited by space charge effect only. As you increase the voltage, current flow also increases. That is, you can see a straight line here. Above 40 kVp, space charge has no influence on current flowing through the X-ray tube. As we increases the potential, tube current is not increasing much. Very slight variation is only visible. So above 40 kVp, space charge has no influence on current flowing through the X-ray tube. This principle does not work. Rather, the current flow depends on the number of electrons made available by heating filament. That is, uh, filament filament current. By increasing filament current only, variations you can see. This region is called as point have difference because difference in the area of difference in the length. So more so the uh, intensity, there will be intensity reduction in the X-ray. X-ray intensity will be reduced from the anode side to cathode side. As a result, the intensity of X-ray decreases from cathode to anode side of the beam. The Heal effect is noticeable for X-ray beams used in diagnostic radiology, particularly for X-ray beams generated at low kVp. To compensate intensity caused by attenuation in the target material. Heal effect is nothing but the reduction in the intensity of X-rays from the anode side to cathode side. The attenuation of X-rays emerging from anode side to the X-ray beam is greater than that of X-ray emerging from the cathode side of the beam. X-rays generated at any point inside the anode must first escape the anode by passing through the tungsten and uranium atom. Intensity of the X-ray beam is higher in this direction because X-ray photons traveling towards the cathode have less metal to penetrate, so escape the anode disk. And as a result, the intensity of the X-rays decreases from the cathode to anode side of the beam. The Heal effect is noticeable for X-ray beams used in diagnostic radiology, particularly for X-ray beams generated at low kVp. To compensate for Heal effect, we can use filter. A filter can be installed in the tube housing near the X-ray beam's exit port. The thickness of such filter increases the anode to cathode side of X-ray. Positioning a patient's thicker position near the cathode side of the X-ray beam also aids in compensating for the Heal effect. Method of reduction of X-ray method of heat reduction is
Yeah.
there are three methods by which heat is dissipated in the X-ray tube. One is conduction, the other is convection, and the third one is radiation. Radiation is method is seen in the rotating anode. As the anode is rotating, heat is radiated out, and the conduction is seen in the anode stem where heat is not it is conducted, and the third one is convection. It is observed in the anode hood. The first step is heat removed from the target area, that is anode, by passing most of the heat by conduction into copper block of anode. Anode is a tungsten material which is embedded in the copper. So uh, the heat from the tungsten is conducted to copper, and from copper it is conducted, and cooling effect is done one in this method. The copper block conducts heat along its length and thus to outside of the tube. The target also conveys a small part of its heat by radiation across the X-ray tube to glass envelope. Through the anode and glass envelope, heat thus reaches the oil and heat is conveyed to metal by convection process. It is then conducted through the casing of the outer surface, and heat is dissipated in the room by radiation process. The three methods of cooling. First one is water cooling, oil cooling, fan cooling. Water cooling is used in the therapy tubes mainly, where anode is cooled by oil, which is cooled by water. And oil cooling is used in both therapy tubes and diagnostic tubes. And oil is also used in to avoid the fan cooling. Fan cooling is used for heat dissipation from anode by means of fans used in low and medium therapy tubes. X-ray production at the anode. The electron hit the anode with a maximum kinetic energy of keV and interact with the anode by losing energy, either by elastic interaction or inelastic interaction. Elastic interactions are rare, and electrons interact by con- con- convert their energy. Inelastic interactions cause excitation or ionization in atoms and releases energy by electromagnetic radiation and thermal energy. Interactions. At, at the anode, electrons can interact with the atoms of the anode and in several ways to produce photons. First is outer shell interaction, second is low inner shell interaction and nuclear field, third is nuclear field interaction. At outer shell interaction, low energy electromagnetic waves are released and quickly converted into heat energy. And second, uh, inner shell interaction produces characteristic X-rays, and third, nuclear field interaction produced by Bremsstrahlung. Interaction with electron interaction with the target. First is uh, excitation in the outer shell. Incident electron interact with the outer shell of the target. Uh, Incident electron transfers all the energy to outer shell and dissipate and displays to a higher energy level. The electron from this outer energy shell displays to higher energy level. Excited electron returns to the original shell and difference in energy appears as heat. Similarly, if ionization happens in outer shell, incident electron transfers sufficient energy and removes electron from the outer shell. Secondary electrons are produced here, and this secondary electrons produces further ionization, which causes heat. The next is characteristic radiation. When electrons interact with the inner shell electrons, if the electrons having kinetic energy, that will hit on this electrons of inner shell, and the inner shell electrons acquires a max energy and it is knocked out of the shell to higher energy level, and this electron then comes back to its original shell, and the energy is released in the form of characteristic radiations. The energy of radiation is the difference in the energy of the shell. A bombarding electron knocks K shell or L shell electron out. Higher shell electrons moves into empty space. This movement to a lower energy state release energy in the form of X-ray photons. The bombarding electron continues its path but is deviated. It is called as characteristic as energy of emitted electrons is depend upon the anode material, not the tube voltage. Energy is released in the characteristic values of corresponding to binding energy of the difference in these shells. For tungsten atom, the difference in the binding energy of K shell and L shell is 59.3 kiloelectron volt. So the uh, X radiation that emitting from tungsten anode is from this having a binding energy of 59.3 kiloelectron volt. So X radiations coming from tungsten is having an energy of 59.3. Similarly, if the uh, electrons was interacting with the uh, M shell electron, and the Binding energy of K shell and M shell is 67.6 kiloelectron volt. So the X radiations that emerging is having an energy of 67.6 kiloelectron volt. Bremsstrahlung radiation. Bombarding electron approaches the nucleus. If an electron is interacting with the nuclear field, Bremsstrahlung radiation occurs. So, a fast-moving electrons while passing near to the nucleus due to the uh, positive Coulombic reaction, Coulombic force of nucleus, the electrons get deviated from its original path. As electron is having negative charge and the nucleus is having positive charge. Due to this pulling of nucleus towards of electron towards it, the acceleration of the electrons get reduced and also this electron deviate from its path. As this reduction in the acceleration, energy of the incoming electron also reduces. So this reduction in energy is released as X-rays. The energy loss from this diversion is released as a photon. This is called as Bremsstrahlung radiations. Bremsstrahlung causes a spectrum of photon energy to be released. 80% of X-rays are emitted by Bremsstrahlung radiation. The word Bremsstrahlung means breaking radiation. Okay. The difference between characteristic radiation and Bremsstrahlung radiation. Characteristic radiation only accounts for small percentage of X-rays photon produced, while Bremsstrahlung radiation accounts for about 80% of the photons in the X-ray beam. Bombarding electrons interacts with the inner shell electron, and in Bremsstrahlung, bombarding electrons interact with the whole atom. Radiation in characteristic radiation released due to electron dropping down into lower energy state, while Bremsstrahlung radiation is released due to deviation of bombarding electron as a result of atomic pull. X-ray spectrum. X-ray spectrum is the plot of intensity of X-ray beam to photon energy. There are two types of spectrum: continuous spectrum and Bremsstrahlung. Continuous spectrum and characteristic spectrum. Continuous spectrum is Bremsstrahlung spectrum. It is X-ray photons of all energies up to maximum. It is also called as white radiations. Characteristic spectrum is a line spectrum. Position of characteristic radiation depends upon the atomic number of the target. Beam quality, the ability of the beam to penetrate an object or energy of the beam is called beam quality, and beam quantity is the number of X-ray photons in the beam. Now, mammography. Mammography is an imaging technique useful for determining the presence of carcinoma or precarcinoma conditions like masses, clusters of microcalcification, and distortion of surface in the structure in the breast tissue. This is what makes and higher energy components to reduce patient dose and to improve image contrast. Optimum energy for spectrum. If photon energy is decreased below the optimum energy, there will be an increase in the dose because the decrease in the penetration through the breast. If we use photon energy below the optimum energy, in order to obtain a proper image, more dose has to be more dose has to be given, or time has to be increased. This increases the patient dose. If photon energy is increased above the optimum energy, there will be an increase in the contrast. Because of this increased penetration through the glandular and pathologic tissues. So the optimum energy for mammography depends on the size and the density of the breast. Mammography tube. The mammography tube is oriented in such a way that the cathode is at chest side and the anode is at the nipple side. This orientation takes the advantage of heel effect to make the transmission through the thicker and thinner part of the breast uniform. Attenuation and sharpness is reduced here. Equipment bulk near the patient head is also reduced. This facility easier patient positioning. Tube positioning. If uh, if the central beam is positioned at the center of the image receptor, because of the shorter sourced image distance used in mammography, the field size will not be sufficient to cover posterior superior breast tissues. So, in mammography equipment, tube is shifted to cathode side such that vertical central ray is directly over chest wall. Under this arrangement, breast is fully covered in the X-ray beam. So, always cathode side tube is moved towards the cathode side in the mammography equipment. The main features of mammography tube is use of target made of molybdenum. In X-ray tube, target is made of tungsten. Here in mammography tube, target is made of molybdenum. Closer spacing of cathode and anode. Molybdenum target anode is placed very near to cathode than in that of X-ray tube. Beryllium window is used for filtration. Beryllium window is used as it has low atomic number, that is 4, and lower absorption of X-rays. So in X-ray tube, aluminum filter is used, and in mammography tube, molybdenum filter is used. Focal spot size of molybdenum target is 0.3 millimeter to 0.35 millimeter, and heat storage capacity is 0.3 to 0.5 MHU. That is about mammography tube. All the physics same as that of X-ray tube.
Man,